Hey students, I wanted to make sure that I went ahead and took a look at the last problem again. Sorry about the sound issue. I'm going to just correct this now. So when we look at the wave amplitude, we can actually count up to the top here, 0.2, 0.4, 0.6, and that's going to be about 0.6 centimeters if I count this off. So again, I can be really strict about this and go from here to here. And then I can be super obnoxious because you can do this on a computer. Just kind of pick it up and we see that it's 0.2, 0.4, 0.6, more like 0.8. Okay, let me just double check that one more time. So there's the, just to be absolutely clear. Right there and right there. And if I pick that up, move it over by the ruler, right on the line. So I'm getting 0.2, 0.4, 0.6. Okay, so more like 0.8 centimeters. Totally fine. So now the period, the frequency is 2.5 hertz. So if the frequency is 2.5 hertz, the period is 1 over that, and that gives me 0.4 seconds. The wavelength can be measured from crest to crest, like that. And let me just try to line that up here. So I'm going from 0 centimeters out to about 2.5. Perfect. So the crest to crest distance is about 2.5. Excuse me, that was really exciting. I hope that woke you up. And so 2.5 centimeters. And so when we get the wave speed, v is lambda f, which is 2.5 times 2.5, and that gives me 6.25 centimeters per second. And then the direction of motion of particles of the wave is moving to the right. It's going to the right. So the particles are going up and down. All right. Now this next part, we get the longitudinal wave versus the transverse wave. And again here, so let's just draw them. Here's a longitudinal wave. And here's a transverse, which I'll just draw as a pulse on a rope. Now, so longitudinal, that's where the compression is along, actually I'll say it this way, the motion of the particles as they vibrate is the same as the wave motion. And for transverse waves, again, it's that the particle motion, the particle vibration is perpendicular to the wave. Now, what do they have in common? A lot of things. They carry energy. They require a kind of medium. And they have a period, wavelength, frequency, speed, such that v is lambda f. A lot of different things. So, I would also say that they can be represented as sine waves, which is this shape, like that. Okay? Sorry, that's a bad drawing. Sine waves, like this. So just kind of a curvy. Now, we can be really strict and actually say that they're a sum of different sine waves. We just kind of write it like this. Now, compression and rarefaction. You know what? I'll be okay if you actually we just kind of draw it like this. Kind of get the rarefaction, and they kind of come closer together again. So we can actually draw it like this, where we have the and then you draw the wave below it like that in this form. And you can actually say that the compression is where particles are compressed, I'll let you get away with that. And in the rarefaction, and in the rarefaction, they're spread out. So here we've got compressed, rarefied, compressed, just like that. Okay. Kind of keeping that in mind, we continue and we keep going with this kind of spread out like this for the rarefaction, compression, yeah. And then what we'd also say is for rarefaction corresponds to troughs. And this corresponds to peaks or crests. All right, so that's kind of a redo. And then here, I'm just going to kind of just say one thing. We're going to not do problem 17. One thing, though, is I want to kind of run through my solution of problem 16. So the idea was that the first harmonic is down here, the second is here, and the fourth harmonic is here. And when we compare, this is about 261. Realize the second harmonic is about twice that, and the fourth harmonic is about twice the second one when we actually multiply it out. So again, this is about 522, and this ends up being about 1,024. Close enough. The idea here is that if we're at 261.2 hertz and these double the previous one, what we're really saying is that each of these notes are doubled and doubled again. That means they're 1 octave and 2 octaves up from the original note.